Here is meant to be a quick video about graphing and solving quadratic inequalities. And first of all, I'm going to say that we should know how to graph equations, and solve quadratic equations. So let's just review real quick what a quadratic equation really even looks like. A quadratic equation would look something like this. Y equals ax squared plus bx plus c. And sometimes in function notation, it's written a little bit different, like f of x as a function, ax squared plus bx plus c. Now we might have different tools at our disposal. We could be doing a graph of one of these using an xy chart. We could just be using numbers randomly or finding the vertex first. Keeping in mind the vertex, the central x value is the opposite of b over 2a. And then you put that number back in to find the associated y value of your vertex, which is the center of these parabolas. So what we want to do is we want to build on what we already know and go through that. Once you have it graphed, it can be helpful, but there's also an algebraic way about going through this using our algebraic tools. So we know algebraically, we know we solve it when we look for the x-intercepts. Algebraically, we might be using something like factoring, and when that happens, then we usually have the set equal to 0. Okay. We could be using the square root method or complete the square, or possibly even the quadratic formula. So like most things, it's not uncommon that we have our own preferences, our strengths and weaknesses as far as our strategies or tools that we choose to use. Okay. So these are kinds of background that we want to make sure that we have going on right now. So let's look at these ones that are already graphed here real quick. And so what we're going to do is these are already graphed. And what it says here is it says x squared minus 6x plus 9 is less than or equal to 0. Now this one I think is kind of tricky because it says less than or equal to. Now if I follow my graph all the way down, what is it? Less than or equal to 0? Not here. Okay. And so it's only less than or equal to 0 right at this point. So my only answer is really x equals 3. Okay, so sometimes your vertex falls right on the x-axis, but my graph doesn't go below that at all. So this is my only answer. However, if we look over at the next one, what we're going to see is if I follow this graph, it says greater than or equal to 0. So I'm looking for where my graph is way up here or equal to 0. So I'm really excited about these points right here. Those are greater than and equal to 0. So if I was graphing on a number line, I would have a solid circle where it equals the 0, and these other x values make this inequality true. So if we wanted to, we could just pick one. So I could state my answer for this is the fact that negative 8 is less than or equal to x, and x is less than or equal to 4. You could also write those out separately. X is greater than or equal to negative 8, and x is less than or equal to 4. So those are kind of our boundaries, so to say, of our solution based on this particular graph. What's different about this one is that it just says greater than. So I would put open circles on my x-intercepts, and where is it above again, right? Greater y values. It would be on these outside values right here. And so this is the part that we really want to work with. So it means on my graph, I would be able to state that the x values I'm really concerned about is that an x is less than between negative 4, negative 6 by negative 5, or since these pieces are not joined together, we can't use the word and. We use the word or. The way over here, x could be greater than 4. Okay, what I also want to do is I want to go through how we would solve this. Okay, so keep in mind where we have all of that blue. We're going to go work on this in red here. It said x squared plus x minus 20. When is that greater than or equal to 0? So the big idea of solving an inequality is to solve it like an equation. Okay, So I'm going to write it as an equation. X squared plus x minus 20. I want to figure out when is it equal to 0. Now, in order to do this, we could use any of those tools we talked about just a minute ago, where we said we could use graphing, factoring, square root of the square, quadratic formula. And depending on the problem and how familiar you are with those tools, you might choose different ones. I myself am seeing that this one will factor, so I could factor it. What are the paired factors of a negative 20 that add up to be a positive 1? So that's going to be a positive 5 and a negative 4. If I'm solving it for, see when it's going to equal 0, what we know is I have to multiply by a 0. So either this first factor equals 0 when x is a negative 5, or the second factor equals 0, I add the 4 on both sides when x is a 4. Okay, so just to confirm, that is what we saw up above. We wrote positive 4 on the right and negative 5 on the left. Okay. However, you could also use the quadratic formula and get these values. The part with the inequality is we make this inequality and we put these, so say critical values on here, like our x-axis looked. Here's my negative 5, my 0, my 4, just to give a little bit of placement value. And we have to test a point in each of these quadrants, or intervals, so to say, a number less than 5. All right, let's test negative 6. So negative 6 squared plus negative 6 minus 20. Is it true that is greater than or equal to 0? So I'm really just putting negative 6 into the very top original inequality to see if it's true. So I get 36 minus 6 minus 20, and that turns out to be a 10. Is it true that 10 is greater than or equal to 0? Absolutely is. Okay, so I know since this is a yes, it should be part of my answer. Okay, I'm going to choose a different color, and I'm going to test the number, say 0. I'm going to test 0. 0 squared minus 0 minus 20. Is it true that negative 20 is greater than 0? No. So I'm not going to shade there. And finally, on the other end, I'm going to go with the grayish blue, and we're going to pick a number greater than 4. What's a number greater than 4? Let's go with a 5. So I'm going to come back up here, and I'm going to say, well, if x is a 5, I'd have 5 squared plus 5 minus 20. So 25 plus 5 minus 20, is 10 greater than 0? Yes. So that would be an open circle since it did not say equals to. And we end up with this exact same number line as our x-axis. Okay, so the number line itself can serve as your answers, or you can write your final answers in a way that portrays it. So x is less than negative 5, or x is greater than 4. Okay, so it could be the number line or that particular graph. Let's look at another one, and I'm going to try and just pick out one of them. I know it's kind of hard sometimes. Quick reminder, if I was to solve this one as an equation, it's already got 0 on one side. I would take out an x. And that's okay to have different strategies. So I would need to test it around a 0 and a negative 3. Okay, let's look at this one. It's a little bit more daunting. So what we want to do is we want to solve it like an equation. So I'm just going to write equals negative 16x. And the first step in solving it as an equation is to set it equal to 0. So I have to decide to move everything to one side or the other. I'm going to choose to move it all to the left, which is unusual for me. I usually try to keep it starting with a positive, if at all possible. Now I could factor this one, and I see it now, but I didn't see it at first. So maybe I'm going to use the quadratic formula. Remember the quadratic formula where we say it's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And what I know is my a value is negative 1. My b value is a 16. And my c value is a negative 64. So lots of negatives I'm going to have to be careful with. All right, so I'm just going to put them into the formula. And I'm going to have x is equal to 1 negative 16 plus or minus 16 squared minus 4 times a times c. It's not going to show you that part on the edge. All over 2 times negative 1. Let's see if I can squish it over. That's really a 64 there. Now, as I go to simplify, I'm going to start with that discriminant, the part inside the radical. 16 squared, I believe, is 256. And 4 times 1 is 4. 4 times 64. Guess what? Well, that's also 256. But it turns out that it should be a negative 256. Now on this particular problem, I end up with negative 16 plus or minus the square root of 0 over 2, which means x is going to be a negative 8. That's where it equals. That's where that point would be on the x-axis. Okay, so now I have to come over here and I have to say, okay, here's negative 8. Is it everything? Nothing? What is it? Now, since it said equals to, I'm going to go ahead and make that a solid circle right there. But we have to test values on either side. So what number is less than negative 8? I'm going to choose negative 10. So go back up here. The opposite of negative 10 squared minus 64. Is that less than or equal to negative 16 times negative 10? Okay. Just checking it out. That turns into a negative 100 because negative 10 squared is 100 times a negative 4. So I have a negative 164. Is it true that is less than or equal to a positive 160? Yes, it is. That's part of my answer. Okay. So next I'm going to have to try a number on the other side. So I'm going to try, say, a 0. 0 is pretty easy to work with sometimes. Well, 0 squared and 0 times anything. This just turns out to be negative 64 less than 0. Actually, it is. So this is kind of like the opposite of that very first graph we looked at. Instead of it having only one point or no solution, this one is really all reals. Okay, so I wanted to show you something with the quadratic formula and try to reinforce the negatives. I wanted to show you some factoring strategies, as well as kind of give you a visual and summarize what we've been talking about with these things.